My assignment is the car price prediction, and the problem statement is that a Chinese automobile company called the Geely Auto, they want to enter the US market by setting up their own manufacturing unit locally, so that they can give a competition to their US and European counterparts. So essentially, they want to know two important things. That is, which variables are significant in predicting the price of the car, and once the variables have been decided, how well this. So they want to check these two parts as uh, they want to check these two parts. So, as part of the data understanding, once the business understanding, we got the idea about the business understanding, we got into the data understanding part. So, there were quite a few variables that we got, and essentially most of these were very straightforward. The variables that we got as the part of the data set were car ID, symboling, car name, fuel type, the door numbers, drive age, engine location, wheelbase, fuel system, bore ratio, horsepower, peak RPM. Most of them were quite pretty straightforward. Not much of not much of understanding was required here. These were all, quite pretty straightforward things which we use it in daily life. So once the data understanding part was done, we got into the EDA and data collection part. First, I checked for duplicates. So we checked for the car IDs and we checked if there are any duplicates. Once that was done, we checked for we corrected the variables. There were quite a few factor type variables which were in character type, or there were numerical types which are in factor types. So we changed them accordingly, and after that we checked for spelling values. Quite a few car companies' name they were misspelled. Say Mazda. These companies, the name was misspelled. Nissan was, and there were quite a few companies where the spelling was correct, but the caps was creating a problem. Say Nissan at times was spelled with the caps N, and at times it was spelled with the small letter N. So we changed that also. Then we went for spelling missing value treatment. So we checked for missing values if there were any. Then the outlier treatment was done. Once everything was done, we created the dummy variables using the model.matrix in R. Once all of this was done, we got into the model building part. So I split the data into two parts: training and test, 0.7 and 0.3 respectively. So after that, I tried modeling with the training data. The step step AIC. I started with step AIC, and so I eliminated quite a few variables that were not very significant. And after the step AIC method, I got a few variables I got that I stuck onto, and started with my second model 2. So I used a linear model. So LM was my formula. With a linear model and the second model, I got an adjusted R square as 0.9722. So with the VIF and P value, we check for the VIF and P values at every intervals, and I saw that whichever P value was, whichever variables were insignificant, I just kept on dropping those. And at after continuous deletion of variables, I got at a point where there were say 12. I got an adjusted value of something around 0.95, which was almost the same. Say something around 0.97 was my original adjusted R square, and at the end, at my 27th model, I got something around 0.95, which was quite fairly, comparable. So I stopped there, and I felt that like these 12 variables were all these variables were quite significant, and explained the price of the models quite significantly. So I stopped there, and once I stopped there, I saw that like I got an R square of 0.877, and once that was done, we checked for I predicted the using the model built. We predicted the price for on the test data. So, and on the test data we got an R square of something around 0.877, which was comparable with the training model, which was 0.95. So something around of approx 7% difference was there, which is quite fine. It was okay. So I felt the model should be good enough, good enough. So after that, we got into white noise check. That was done. So basically, after this model building, the conclusion was that like there are 12 main variables that predict the car price very significantly. Some were like engine location, car length, horsepower, number of cylinders, and there were like derived variables which explained the car pricing very significantly. Like there were like car height weight ratio, car height length ratio, and power to weight ratio. They were quite these were the variables that significantly predicted the car price. And variables like cylinder number, car height weight ratio, and power to weight ratio are like negatively dependent variables. That is, the increase in these variables decrease the price of the cars. Other variables are positively dependent. So depending on these variables, what I felt is any managers or the higher authorities, they can predict the price of they can predict the price of the car reasonably. That's what I felt. So that's where I ended my model.